a little note that says anything with an asterisk, know it under a microscope slide, disregard that. And we've already talked about how the difference between arteries and veins has nothing to do with oxygenation, so you guys all know that already. The difference is in thickness, and now we're going to get real specific about that thickness. So on the left you see arteries, on the right you see veins, and they're connected by a capillary bed. So there's three levels no matter if you're an artery or a vein: tunica interna, tunica media, and tunica externa. So those are three general levels in bold. Now we look at the artery on the left-hand side. You've got two main inner layers plus an elastic layer. So you've got endothelium there, those squamous cells that are lining your capillary, lining all blood vessels and or lining the inside of the heart. We called it endocardium in the heart, but it's the same thing. So endothelium is your most inner layer. Then you have a subendothelial layer, which is also called the basal lamina. If you remember that from the second week of school, this is what's always associated with epithelial or endothelial tissue. It's basically the glue that holds the squamous cells down. But what's important is just beneath that is an internal elastic lamina. Elasticity is really, really important in your arteries. This is something that we lose with age. And this is something that can lead to organ damage because the stiffer an artery is, the higher the pressure it is when it gets to your organ. And so this is what complicates this whole pressure thing, is you want very elastic arteries up to a point. You don't want them too elastic. You don't want them bubbling. But you want them to be able to absorb some of those variations in pressure. And part of that is this elastic layer on the inside. And you'll actually see another elastic layer next. So that's it for tunica interna, basically just three layers there. Tunica media is the important one for distinguishing arteries from veins because tunica media is way bigger in arteries than veins. Tunica media is made of two things: smooth muscle and an external elastic lamina that is usually only found in arteries. So arteries are going to need more elasticity, they're going to need more muscle. Because if this is your job as an artery to constrict and relax to manage blood flow, you're constricting against mean arterial pressures that range from 93.3, like we said there, and can get up super high. And so you need to be really strong as an artery to be able to deal with the really high pressure fluid that's going to be moving through this tube. Whereas the veins, because you're dealing with anywhere from 0 to maybe, if you're Curtis, 60 millimeters of mercury, right? And rarely is that going to happen. You still need some muscle, but you just don't need as much because the pressure you have to push against is less. So don't think that the veins are less important for managing blood flow and constricting and relaxing. They actually do it more and are more important for that than arteries. But because there's less pressure in the veins, you just don't need as much muscle in the tunica media. And your veins aren't as elastic, which is why they're more likely to rip in traumatic events. Tunica externa, that's basically just connective tissue around the outside. For large arteries, they actually have arteries on arteries to serve the muscle of the blood vessel. It's actually how big some of our arteries get. So you may see some blood vessels on top of blood vessels out there. But as we move through the respiratory system and the digestive system next term, you'll see that basically all the tubes in our body have some kind of external layer around it. In this case, we call it the tunica externa, but you're going to hear it referred to as the serosa and the adventitia when we get to the digestive system. But again, just connective tissue around the outside. So we got a model that illustrates this pretty nicely, actually. It's really similar to the picture that we're looking at here. Back here, so there's veins going around the outside, an artery down the center, and the front of it comes off so you can see the individual layers. Also, one other big difference between arteries and veins is that veins do not have this high unidirectional flow, right? Veins have such a low pressure that blood can actually kind of go both directions. Let me rephrase that. It could go both directions if it wasn't for valves. So you have valves in your veins, you have valves in your lymphatic vessels, and this is because if you don't have the pulses, this high pressure forcing blood to go in a single direction, with your veins, if I swing my arm like this, all the veins, all the blood in my arm wants to go to my hand. It's being prevented from going to my hand by the valves, preventing backflow. Really important in your legs, so as you get down into your feet, that pressure is going to get high, and most valves is 35 to 40 millimeters of mercury in our feet, so that's gravity pulling that down. And so these valves expand. They're just one-way passive valves. You don't have any control over them. But that means that when blood does, like you constrict your calves, and you blow the blood up basically, really abruptly, and then when you stop doing that, the blood wants to fall down because of gravity, but the valves open up and stop that. So that's the hope. Valves do break in veins, especially due to like extreme pressures, pregnancy, just old age. Eventually you're going to break a couple of them, and then you'll get pooling of blood in the veins. It's usually more of a problem in the superficial veins, because the superficial veins, like the saphenous vein in the back of your calves, they don't have muscle around them to help them pump. So when they start to stretch, they just keep stretching and stretching and stretching and stretching. For young people, it's more of a cosmetic thing, but as you get older, it will predispose you for developing blood clots in those veins, and that can actually be dangerous. Sometimes they will remove them as a precaution if they get bad. And they call that varicose veins in general. All right, so that's it for the layers. Last thing I want to talk about before I let you guys kind of